All right. So what do we know regarding the strengths of LLMs? For example, they know a lot of stuff. As a starter, we know that LLMs really knows a lot of stuff as they are trained with very large data sets of different topics, regardless of they are acquired legally or not. This means that, for example, they are more likely to know which LibreOffice source directory contains the functionalities of interest, even when it doesn't read any of the code. It can save us a lot of time to locate the proper source files to look into our problems. Another thing that we know is that it can read code super fast. LLMs can read hundreds of lines of code and have a guess of what it is doing in a matter of few seconds, which is something us humans can easily do. It allows us to understand unfamiliar code more easily without figuring them out line by line. They can also do simple or repetitive tasks. LLMs can complete easy repetitive tasks such as batch naming identifiers and function names, and thus we don't need to spend our time in these mundane tasks and work on more constructive ones. Now, what is the weaknesses of LLMs? For example, they aren't actually really that intelligent. Essentially, the algorithm is to predict the most possible word to appear next, and it can struggle on some complicated tasks very easily, such as do basic calculations. They also will easily hallucinate because they are trained using different topics of data. For example, it may return data that is sourced from the programmer humor subreddit post. Yeah. And they also have a knowledge cutoff point because they are trained with data from months or even years ago. So you will get outdated responses. However, there are still some recent technology advancements that can fix some of these weak points. Now LLMs know how to use tools. For example, we have something called Model Context Protocol, or MCP, so that the models can, for example, use for a grep tool to search your code base using certain keywords. They can also use web search tool to search for example, the correct package names of the latest Ubuntu release, so they don't suffer from the knowledge cutoff point. And they can also run comments for you in the terminal and receive the output to figure out what to do next. And they also know how to read instruction files from us. There's something called agents.md, or they might be different names, but in markdown files that contains instruction on how to work your personal or project-specific needs. There's also another thing called skills, which is the model can selectively load certain instructions for their specific tasks. Now we talk about what are the dangers of using LLMs. They can be destructive and sometimes even destroy your data. For example, some days ago, there's the anti-gravity AI editor who delete the entire D drive of a user. Yeah. They can subject to prompt injection attacks, so that it can sometimes be confused the user data as instructions and run them, and sometimes they can store your secrets and upload it to a server that the attacker can access. They also build up technical depth to your project very fast, as the results of the responses you can really know much about them. So it usually results in a maintainable net mess, and also
a more unmaintainable mess than we usually make.
Yeah, especially. And for users that make very use of them, they actually learn less because they don't really figure out how to solve the problem the AI model do. So they didn't get too much experience during the process. And they might even waste more of your time than preserving it, because now you need to code review AI's the response constantly, and it might take more time than you just write the code directly yourself. Okay, now we'll show some cases where we use LLMs to solve some bugs in LibreOffice. For example, there is a bug that in a Word writer document we can't cut a fontwork object. If we press Ctrl X, the object doesn't disappear. Yeah, and this is the bug we are not talking about. So to debug this issue, I executed the following prompt. I asked the LLM to give me some inspiration where I can put my debugger breakpoints in the source code. And this is the response. Sorry, it's in Chinese, but it essentially tells you, hey, you can put a breakpoint here and here, and we can know more about this issue. So this is the actual screenshot of me debugging this issue, and we essentially result in a patch that actually fixes it. Okay, now here's another case from Jeff that fixes a certain wrongly rendered Chinese symbol bug.
Okay. This bug is related from contention symbols. You can see we have
this one. To the right. Oops. Okay.
You can you can see this bug is related another previous bug fix. It is also fix same fonts called 标楷体. computation symbols will be overlapped on the words like yes, you can see there are two brackets, and upper one is overlapped with another words like it is font. It should be like it is correct one. It is because this is because LibreOffice code has allocated specific face for this, but because it uses Outbox as font rendering engine, but Outbox in some versions we are investigating, but in some versions it is fixed for this font. So this code will be it's originally done. It will overlap in upsides outside. It will be workaround for previous version, but the newer Outbox version it doesn't work and will be produce another bug. So we originally think just remove this code to fix it, but you can see. But you can see because our LibreOffice configured AC says our Outbox minimum version is 5.1.0, but so it is fixed in newer version, but we don't know what version is fixed, so we are still working on it to find what's Outbox version to fix it, and it says we should use if ones to fix this issue, but not removing all codes about that. So we are still working on it to find Outbox version to check on this issue.
Okay. Now we are going to close up and share what we learned during this process. Okay. After experimenting with large language models, we have learned the following recommendation. Like, we don't really have the slides though. Yeah. Wait a second. We don't really have the slide for that one yet, so I'm just going to read it. Yeah. Okay. We have the following recommendation. For example, only use large language models in places where the time consumption is known to be lesser than not using them. And also, use them to inspire you to solve a problem rather than doing the job for you directly. And I will also recommend to catch up technical debts built up during the process so that you won't end up in an unmaintainable code. Okay. And that's all for now for us today. Thank you.
Questions? Yeah, time for questions.
Yes, yes. So do you have any questions?
Okay. Do you know how many, or can you estimate how many commits so far into LibreOffice have been made using the help of LLMs as debugging tools, as opposed to just asking something arbitrary in ChatGPT, but something that's more concrete to our code base?
I have no idea. If you mean that how many comments are in the LibreOffice are based on LLM tools, I have no idea. However, I do believe that we should follow, for example, like KD projects to announce a policy regarding the use of AI tools in contributing LibreOffice. Yeah.
Okay, thank you very much. Other question? No? Okay, I have a question. Thank you very much for speaking. About your mention about the tools for debugging. The debug of the tools in Chinese, right?
Yeah.
So is it work in our country language? Japanese.
If you mean that if you can use Japanese native language in debugging, I believe it is yes.
Okay.
Yeah, because large language models are really good at understanding different language and responding them using the same. Yeah. In my previous example, it responded me in Chinese because the code editor I use have a default prompt to always use Chinese, the system language to reply. Yeah, that's not actually what I wanted, but it's ended up that way. Yeah.
Okay, thank you very much. Okay, thank you very much for this speech and clapping. Thank you very much. All right. And next page